Good evening, everyone. You asked me to give you a little bit more help with the exponent work that we did today during class. So we are going to do some more stuff together. Let's look at this first example. So it asks us to complete the steps for solving the equation. Write the numbers, variables, or expressions in the blanks. You'll notice it actually is telling us the steps here so that we can follow along. So let's start out. We start out with 81 to the x plus 6 equals 243 to the 2x plus 5. Both of those numbers can be expressed as powers of 3. So 81 is 3 times 3, which is 9, times 3 is 27, times 3 is 81. So it is 3 to the 4th power. And 243 is 3 to the 5th power. Okay, so now I have 3 to the 4 times x plus 6 equals 3 to the 5 times 2x plus 5. 5 times 2x plus 5. So at this point, we are going to write an equation just using our exponents because we have the same base. So I have 4 times x plus 6 equals 5 times 2x plus 5. I'm going to use my distributive property. So 4x plus 4 times 6 is 24. 5 times 2x gives me my 10x. 5 times 5 is 25. So then I'm going to, obviously, I'm subtracting the 4x. So I am SPEing 4x, and I'm going to SPEing 25. They did them both on one line. I wouldn't, but whatever. So when I subtract 4x from both sides, I get 6x on the right and negative 1 on the left. Divide by 6 on both sides, I get negative 1/6 equals x. So the solution is negative 1 over 6. So I like this one because it actually gave you the steps over here that you can follow to see what you're doing. Let's go on to some more examples. So this is an entire sheet of examples. Let's start up here at the top. First part asks us to write each radical. These are our radical symbols using a rational exponent. So I need to change the 4th root of 7 into a rational exponent. So that is 7 to the root's power 1/4 power. Remember that there's automatically a 1 here. If I come over to 2, I'm going to still have my 10. And then this is the numerator of my fraction. The root is the denominator. Pretty easy, right? Move it over. I have the square root. Remember that there's always a 2 here. We don't see it. So this is going to be a to the negative 3 over 2. Or you could write, if you do want, you're the negative 1 over a to the 3 over 2. And finally, I'm at number 4. Once again, I keep my base. This becomes the numerator. This becomes my denominator, a over 3. Pretty simple, right, guys? Let's come down and do some of the ones that are a little bit more difficult. Ooh, turn that. So, solve each equation. Here, do this in a different color because I'm tired of red. I've got 4 to the 14th and 4 to the x over 2 and 4 to the x over 5. So I know that the product of powers rules tell me that this is the same thing as 4 to the x over 2 plus x over 5 equals 4 to the 14th power. So I need to add x over 2 and x over 5. Their least common multiple is 10. So I've got 4 to the 5x over 10 plus 2x over 10 equals 4 to the 14th. So 4 to the 7x over 10 equals 4 to the 14th power. Now I'm going to rewrite this, setting my exponents equal to each other. So this exponent equals this exponent. So I have 7x over 10 equals 14, which gives me 7x equals 140. So x equals 20. Any questions on that? All I did here was, so all I did here was I'm adding my exponents because this is the power of powers product of powers. And I left this alone. Once I had them combined into one term, I set them equal to each other. And I solved it. Not real hard. Let's do another one. So, once again, I have a product here. So I'm going to add my exponents. So I have 2 to the 2x plus 2 plus 3x minus 7 equals 2 to the 25th. I can stop right here and eliminate these bases because I have the same base. So I'm going to set my exponents equal to each other. So now I have 2x plus 2 plus 3x minus 7 equals 25. Combine my like terms, I get 5x minus 5 equals 25. 5x equals 30. X equals 6. Not too bad, right, guys? Let's come down to some of these that are a little bit different. Oh, I'm going to do number 7. I lied. I like number 7. That looks fun. So we have our quotient of powers here. First thing I have to do is rewrite all of these in base 2. So 8 is 2 to the second power. And then I'm going to carry that x over 2 here. Divided by 4 is, I'm sorry, 8 was 2 to the third power. 4 is 2 to the second power times x over 3 equals 2 to the negative 5 over 2. So, going to raise 2 to the third power to the x over 2 power. So that gives me 2 to the 3x over 2 divided by 2 to the 2x over 3 equals 2 to the negative 5 over 2. When I'm dividing my exponents, I am going to be subtracting. When I'm dividing two powers, I'm subtracting my exponents. So I have 2 to the 3x over 2 minus 2x over 3 equals 2 to the negative 5 over 2. I'm going to go ahead at this point. I have the same power here, same bases. I'm going to set my exponents equal to each other. So I have, let's undo that. Sorry, guys. I have 3x over 2 minus 2x over 3 equals negative 5 over 2. So the first thing I'm going to do is I need to combine these ones on the left. So I'm going to make them all powers of 6. So I end up with 9x over 6 minus 4x over 6 equals negative 5 over 2. 9x minus 4x gives me 5x over 6 equals negative 5 over 2. Can multiply the whole thing by 6 over 5. Gives me x equals negative 30 over 10. So x equals negative 3. X equals negative 3 is my final answer. So that was lots of steps, but wasn't lots of difficulty. Let's look at one that's a little bit more difficult now. You come down here to this word problem. A triangle has a base of x to the 1/2 powers meters and a height of x to the 3/4 meters. If the area of the triangle is 16 meters squared, what are the base and height of the triangle? So the first thing we need to remember is, what is our formula for the area of a triangle? Area of a triangle is 1/2 base times height, or base times height over 2. So my base is x to the 1/2. My height is x to the 3/4. You divide this whole thing by 2, and it equals 16. So the first thing I'm going to do is multiply by 2 over, so that I'm left with x to the 1/2 times x to the 3/4 equals 32. I'm going to combine my x's. 1/2 plus 3/4 is x to the 5/4 equals 32. So how do I get rid of x being to the 5/4 power? Just like when we had x to the 1/2, we're going to raise it to the reciprocal power. So when I raise both sides to the 4/5 power, 4/5 power, over here I'm left with x. Here, I need to take the 5th root of 32, which is 2, and raise it to the 4th power. 2 to the 4th power is 16. X equals 16. How did I know that? I know 32 is a power of 2 because it's 2, 4, 8, 16, 32. These numbers should seem familiar. 64, 128. Anyone know anything with computers? 256, 512. These are all memory units. These are all the powers of 2. You'll need to know them. So I knew 32 is a power of 2. Because I knew that I was able to do the rest of this. 16 is a power of 2. 32 is a power of 2. All of it. Okay, so try these on your own. Good luck, and I will see you all at 9 o'clock tomorrow if you need additional assistance.